Welcome to Ask and Learn.
They want us to show that every finite lattice has a least element and a greatest element. All right, well, remember what it means to be a lattice. This means that every pair of points has a greatest lowest bound or a greatest lower bound and a lowest upper bound. Yeah, so let's just keep that in mind when we're doing this. So let x1 dot 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 all the way up to xn be our points of a finite lattice. Okay, so what we want, so this is what we want to show here. We want to show that the greatest lower bound of essentially all of these, so x1 dot 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 all the way up to xn is equal to g. And g is just some element x1 up to xn. So this is what we want to show. And likewise, we want to show that the least upper bound of x1 all the way up to xn is equal to L, which is also just one of our points here. Okay. So we're going to actually use something we've shown previously. So if you haven't watched the video on number 45, I would do that because we're about to use that result. So what number 45 says, though, is that every non-empty set of a finite lattice has a least upper bound and a greatest lower bound. And, well, x1 to xn is a non-empty finite set of our lattice. I mean, it's the whole set, but it's still one. So if we take the lowest upper bound and the greatest lower bound of these, we should get something. So let's go ahead and write that. All right, so by number 45, since we assume that we have a finite lattice, the least upper bound, and the greatest lower bound of the entire lattice exists. So call the greatest lower bound of x1 up to xn g, and the least upper bound of x1 dot 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 up to xn L. Well, since G is so remember this is the greatest lower bound for everything. So since G is a greatest lower bound for the entire lattice, this means that G, so remember what it means to be a lowest bound or a lower bound is that it's below everything. So this is going to be less than or equal to xi for all, so for all I elements of 1 up to n, which then implies we have a minimal element, or a least element. Of course, it would be a minimal, but it's more so a least element since it's dividing all of these. All right, and now similarly for the least upper bound, we'll do that same thing. So likewise, L is a least upper bound for the entire lattice. And this means that xi is less than or equal to L for all I element of 1 to n. And then, then this right there, also this should be this. This implies that we have a greatest element. So that would be our proof for this. So now that you're done with it, you can put your little proof box and a smiley face because you're glad you're done with the proof.